And the next speaker I would like to welcome on the stage is a founder and network automation lead at Netomate, Mr. Basem Al-Sabri, and his presentation on the network automation blueprint. Go ahead.
Good afternoon, everyone. We've had some interesting talks today about network security, network privacy, and also to resilience. And what I'm going to be talking about today is a subject that I'm greatly passionate about, and that's like network automation. And what I'm hoping today is by the end of this talk that organizations who are like starting or thinking about network automation would be more motivated and have a clearer idea of where to start. And for organizations that are already on their way, they have like a few things to improve on. And just by show of hands, how many organizations here or teams think they have more than 20% of their operations automated? We've got a few hands, 50%? 70%? Okay, we've got some advanced players here. It's good to see. So just a brief introduction about myself. When I was doing my CCNA a while back, and the moment that I was able to configure my first two routers to be able to speak to each other and I got my first ping, that's kind of like when I figured out that I would be a network engineer. And I thought I had figured out the internet out. 14 years later, I'm still trying to figure out the internet. And so I've always like enjoyed doing networking. It's been always like fascinating to me, but there were always like parts of the job that were not like that were boring to me. So like doing things repetitively, like doing the same commands again and again. And so for me, like the switch port access VLAN command was always the one that I was doing the most. And I've always had ideas of how to improve things and reduce like the iterative thing of doing the same thing again by doing like shortcuts, doing aliases, like doing templates. But that there is so much that you can do with that. It was only when I joined AWS that I was exposed to network automation, and then I was exposed to how powerful network automation can be. So things that used to take me, let's say, 1 week to configure a switch, and now with a click of a button or like within 1 day, I'm able to configure like 100 switches. And that was not because I suddenly became a super engineer, but just because the network automation and the tooling is way advanced compared to what I was before. And that's kind of like what I fell off with network automation. And after that, I just specialized in network automation, and then seeing the gap that there was between hyperscalers and the rest of the industry, that's kind of like where I came up with the idea of starting Netomate, and that was kind of like to bridge the gap and to bring like network automation to the rest of the industry. So in terms of like what we're gonna discuss today, we're just gonna have a look at like network automation. What are the challenges that we're facing? What is the reason, or why would we want to do like network automation? We're gonna go over some of the challenges, and we're just gonna have a bit of a look in terms of like adoption roadmap, like what would it look like for a company or a team that's new to automation. How can we lower the barrier to entry to network automation? We're going to look at a few approaches. We're going to discuss network as code, and then we're going to talk about how to measure success. So if you look at the state of networking today, and that's been touched upon by some of the speakers, is we always have like a growing demand on networking teams, and that's like through new technologies or demand for new capacity. There are like an endless amount of drivers that that increase the demand on networking. But what we see as well is like network engineering teams have been growing in a like not as much as the drivers that are putting like pressure on networking teams. And that's mainly because like networking teams still rely to a big degree on CLI, command line, or on just like GUI to click through. And we also have like siloed tooling. So we have like network monitoring tools. We have different tools that an engineer deals with on a daily basis. I've actually been in places in which let's say as a network engineer, as I'm doing deployments or operations, I had to look at like 5 different dashboards. There is a limitation to how many dashboards like an engineer can be looking at. And so all this just creates like a big gap and creates like challenges for networking teams. And what I propose is like with automation or with network automation, we're able to bridge that gap. And so when we talk about network automation, is like what is the reason we need network automation? And as we discussed, there are those challenges. But if we look a closer look, like network automation allows us to deploy faster, to be able to like things that would take us 8 hours to do, that reduce that to minutes. But it takes time to reach that, and that increases like the agility that we do for our networking. And so a recent study by ADCG says that like automation has the potential to reduce the time to launch or the time to delivery by 85%. And the same study as well suggests that we can actually reduce OPEX by 55% with automation. Of course, these things, they do take time, and that's kind of like one of the reasons why automation is still not widely adopted by enterprise and by service providers, because it generally everyone is under pressure to deliver, and with network automation you don't get the results straight away. It just arrives with time. And the last thing that network automation allows us to have is to reduce the risk of deployments, and that's something that's was not apparent to me in the beginning. When I started network automation, it was mainly about the efficiency and about saving time. But then as I was talking to more clients and more organizations, and I found that reducing risk is actually one of the key factors, because organizations want to reduce like outages. And yeah, a study by the Uptime Institute says that up to 80% of outages are actually they come from human error. Well, someone might say like does not like network automation might actually like increase the chance of error, or actually increase the blast radius, because if we are configuring, let's say 10 switches as opposed to 2 switches, if we make the mistakes, then that just increases the blast radius. And that is correct. And that's why it's really important when we adopt network automation or we invest in network automation, we really not just focus on deploying faster, but we really need to invest in the safety. And one of the reasons, one of the ways that we can invest in that is by really investing in automated pre-checks and post-checks. So if you're deploying BGP, we need to have like every check that an engineer does before the deployment and after can be automated. For example, if you're deploying BGP, we can have an automated check that would check that the IP address does not exist of the neighbor, that the BGP is not already there established. We can also check after. That's the same thing if we're configuring BGP or OSPF. We can check that the OSPF has been established. We can check the number of routes, and all these things can be automated, and they can like radically increase the safety of our deployments. And another thing with network automation is progressive rollouts. So before we roll out network automation, we need to really test our workflows in a development environment thoroughly. And even when we release that to production, we need to do that in a progressive way. So if you're configuring BGP, for example, we start by doing only on 2 routers, and then we do that for 10 times. And then once the automation workflow have stood like the test of time, then we increase gradually. That way, we make sure that what we're deploying is safer for production. So when we talk about automation as well, there are like certain prerequisites that we need to have in place in terms of like network automation. And if we talk about from the organizational perspective, the first one is skills development. Like the main ingredient for network automation is the ability to be able to codify manual processes. That's mainly generally like a programming language like Python, but there are other ways, other programming languages. There is also like Ansible, which is a tool. It's not like a programming language, which kind of like eases the barrier to entry in terms of like not needing to have. But the main ingredient is to be able to take a manual process and convert that to an automatic, and that's like through codifying the deployments. So we really need to invest in the skills of network engineers and to be able to do that, or at least bring resources from outside who can help can help with the network automation. So that's the main basic ingredient. The second one is like leadership buy-in. And so generally what I've seen is leadership generally like requires engineers to automate, like in addition to kind of like doing also their work on the side, like doing their changes and without any impact to the speed of deployment. And so what we really need to have is to have leadership like invest in either, let's say, limiting the number of deployments, that way engineers can then focus on automation, or bringing extra resources to help with the automation. So that's why like leadership buy-in is important. If you have one engineer or your champion engineer doing all the deployments and then doing automation on the side, there is so much that you can achieve by doing that. And the third one is adaptable processes. Like once we start investing in automation and we go in that route, we really need to take into consideration that the processes that used to work for us for like manual or traditional networking will need to evolve with time as our automation progresses. So for example, I've seen environments in which you need to go through like 4 approvals to get a deployment change. And so with automation, if the automation has been proven in production, we need to kind of like move into like a more adaptable process. And from the technical perspective, when we start like doing automation, or like before we start like coding, if we don't have defined processes, it's really, really hard to automate. If every deployment or every operation is manual or is ad hoc, and so like every engineer deploys in a different way, or is we have like tribal knowledge, so like there is no way that we have like a defined process, then it really becomes hard to automate. And so we really need to have defined processes. We need to have like our standards in place that would include like naming conventions, ways of having the subnets, BGP. All our standards need to be kind of like in place to really ensure smooth automation. And this all kind of like comes from having defined patterns. So if we have defined patterns to say, let's say our team goes through VLAN changes, and so that's like a defined pattern. BGP, let's say, is configuring new BGP is another pattern. So by having defined patterns, then by having defined patterns, that kind of like really enables us to build our standards, to build our processes, and then we can automate. So I recently was in a AutoCon, which is a network automation conference, and 2 themes that were emerging in some of the talks and in some of the hallway talks was the way to approach automation. And the 2 thoughts were like, we just need to like get started, start writing code, start automating, and then like build on that. And then the other one was, now we really need to kind of like sit, think, and design. And then that's how we kind of like build proper automation. And there are like pros and cons to each of these. And I think there is also like a middle ground that we can reach. So for example, with Just Code It, that's how you get like, let's say you have like a low barrier to entry. So you're able to just start like using like small use cases, and you tackle them, you save the hours, or you get the benefit from that, and then you move on. Whereas with design driven, it really takes time. So there is like a higher barrier to entry. The other one is quick wins. So if we just like start coding, we can start like with using like small use cases that we can like benefit from. We can get like some buy-in as well when we have those quick wins. Gives us the learning, gives us the leverage to continue with our automation. Whereas with design driven, it really does take long time to delivery, and you also need a lot of skill set to be able to design. You wouldn't ask like a newly graduate network engineer to design like an MPLS core, and for the same reason, like you wouldn't be able to ask a new organization who's like new to network automation to kind of like design their automation framework. You really need to incorporate the learnings. And so when it comes to the disadvantages of just winging it and just like coding it, like you end up like with fragmented code or fragmented scripts. And so that's something that you need to kind of like consider with time. Whereas with design driven, because you've done your work from the beginning, you're able to scale. And the second one is like you really reach scaling limits with just coding. Whereas with design driven, if you've done the design properly, then you can easily maintain. And I think like the way what I can say about this is how we can marry these two is, if you're a new organization, new to network automation, that what you really need to do is you start with just coding it. You just try to get there and get the value from network automation. And as your experience progresses and as you get like more wins from network automation, then you slowly like graduate to kind of like a design driven approach. And we'll have a look in the next slide of, let's say, like a simplified adoption roadmap. So what we have here is we have, let's say, the effort that we put towards automation or the time that we invest in improving network automation in our environment. And then what we have in the vertical axis is impact, or the value that we get from network automation. And so if we start with just coding, and that's like the basic ingredient to automation is to be able to write code coupled with the domain knowledge of networking. So you identify your small use cases that you can automate, and that can be with Python or Ansible or whichever programming language you are fluent with, and you just like write code. And then you identify your use cases, you automate, like you get like nice value. But then as we can see here, like then you kind of like reach a scaling limit. If you're just like writing code and then you're sharing that code with your colleagues via Slack or email, you'll reach at a point in time in which everyone has different versions, and you'll be asking, oh, are you using the one that I sent you in email or the one in Slack? And so like you'll notice that you're gonna run into issues that are gonna really impact the value that you get. So we really need to like start introducing version control, and that's via Git. And that's how we make sure that everyone is using the same version, and we get to improve our network automation as we go. And I know that if there are any DevOps guys here or software engineers, they'll be like, why don't you introduce version control from the beginning? And the goal here is to really reduce the barrier to entry. So we just like start with coding. And because generally for network engineers, version control is something that's new and it's very foreign. So we try to really reduce things to the basic ingredient, which is coding. And then once, or hopefully like before we even start running into those issues, we introduce version control. And then with version control as well, we get to an area in which like there is so much that we can scale. And that's when we really need to introduce tests. And when I say tests here, I'm not talking about network tests. I'm talking about code tests, and that would include functional tests, which kind of like really test like your workflow from beginning to end. And then you have unit tests, which really test certain functions in your code. And that way that you're making sure that when you're updating your code, which is something very common, whether you're adding a feature or fixing a bug, you're not breaking other parts of your code. And at this stage, like it can be like manual tests. And then the next step is to actually introduce CI/CD pipelines, that's continuous integration, continuous detection, and that's basically like automated pipeline that like takes your code, does the test, and then deployment to your environment from which like you're running your code. And so with that as well, we can see like with each thing that we add, it kind of like allows us to like improve our automation framework and go from that. And then after CI/CD, we get a single source of truth. So single source of truth is it's like our repository or our main place in which like we kind of like gather all the variables that we need for automation. So you have your let's say when we are doing our deployments as network engineers, we have different areas that we get. Let's say you get your IP addresses from IPAM, you get your BGP from the wiki. So there are various areas that network engineers have to go and query different tools to be able to deploy it to the network. And if you're doing automation and you're going to these different tools, you start to run into issues in which like things are not synced. And so that's where you have a single source of truth that kind of like helps like grow your network automation. And now you'd hear like it's a very common term, single source of truth. Some people might call, if you're familiar with Netbox, it's one of the like inventory systems. People would, many organizations would use that as their source of truth. And so, yeah, if we look at this, now, we see like if we come to a new network engineering department and we say, hey, like you really need to implement network automation and you really need to implement all of these, and we're coming to a new team, it's going to be like very overwhelming. And so that's why we start like introducing these things one by one, and that way like it's a simple approach that we get the value. So some common like anti-patterns or pitfalls that I see like some teams go into when adopting network automation is the trying to automate everything. So let's say once there is the buy-in and then they want to automate, they start by like, okay, we're going to automate everything. And automation does take time. So you really need to kind of like pick specific use cases, use those to like as a proof of concept. If you're coming from a traditional networking background, use those as a proof of concept that there is value in network automation, and then you scale from that. So we need to start with small and high impact use cases, and then we grow from there. The second one is the approach, and that's waiting sometimes for the perfect tool or the perfect architecture. So like trying to really design your network automation and really taking the time, and then you get like stuck in analysis paralysis. Or sometimes you have to kind of like wait for the vendor to your networking vendor to come up with a solution to some of the repetitive issues that you're facing. And so it's always good with network automation to start with something that is good enough, start with something that really just like improves your baseline from where you are, and then you keep that iteration. And the last one is like chasing for like trends or shiny tools. And there is like plenty of those. And what we need to do here is really like focusing on solving like business problems or having things that are really yeah, so we really need to focus like on solving like business problems or things that really improve our baseline in the networking team. And so when we in many of the chats that that revolve around network automation, there is always like one area or one subject that really takes like the center stage, and that's config deployment. And that does make sense because at the end of the day, everything we do as network engineers is at the end of the day to kind of like deploy config on the switch. That's kind of like the main goal. But there is a lot that goes behind the stage to make like network automate, like to deploy that config. There is a lot of design. There is like a lot of allocation work. So that's like allocating BGP, IP addresses, port reservations. Um, there is a lot of work that goes into before we actually able to deploy the config on the switch. And so that's to me like that's actually like a better place to start automation because it's a lower risk or a lower place to actually like start doing the automation in. And so here we just take a quick look of like what are the other areas, because I'm always asked like what can we automate, and what we have here is like some of the areas that we can actually like automate or like use cases for automation. And I've just like kind of like just color coded them based on what I think is low effort, what is medium, and what is high effort. And as we can see, like config deployment is kind of like in the middle. And the reason for that is because you're touching like live devices, so there is always a lot of consideration that you need to make sure to like that you're not breaking the network. And if we look here on the left side, we have config generation. So kind of like split config management can be split into two areas. So you have config generation, which is just like generating the config that you put into the switch, and that one is easy because it's almost like a find and replace. Um, and so we also have like guardrails. This is like the automated checks that we do for deployments. And that can be like before and after. Having these like automated checks is an easy and all-in. And I think to me, like the easiest one is the allocations. That's probably like one of the areas in which I generally, in new environments, that's kind of like where I start. Because you, like the chances of breaking something is almost like non-existing. If you're allocating VLANs, true, like you can like mess things like in terms of like the reservations, but there is a lot of room to catch the errors. So like things like interfaces, VLANs, IP addresses, BGP, rather than having them like in Excel sheets or in wikis or in wiki pages, it's just good to have them like auto assigned in a central repository that you can like double check. Other things that we have here, we have security policies. Security policies, I would say, is probably like one of the best areas as well to do like network automation. They're like one of those high volume, highly repetitive places, and especially if you're only doing if you're doing only like allow statements, then it's like very relatively safe to do. but it can get a bit more complex if you're talking like end to end. So in some environments, and when you have like zero trust architectures, that's when kind of like if it gets a bit more complicated. But if you're talking, let's say, about like one firewall or one endpoint that you're doing that, then it's relatively simple. Other areas that we can do is like OS upgrades is a good area where we can do network automation. And then another area is tooling integration. So in every network environment, we generally have all our tools that we kind of like need to query and use for different areas. And usually they don't talk to each other. And with most of them, they generally like have APIs. So we can always like programmatically make sure that they talk to each other rather than the engineer going to the first one and then going to the second one. And in times in which they actually don't have APIs, usually you can actually export things to sheets, even though this is like a less glamorous way of doing things. It's still like a good way of exporting things to an Excel sheet and then having like a script do the work. And then we have like on the right side, we have like the advanced, and those are like really kind of like advanced use cases, and they're like very complex to implement, because like we talk about self-healing and traffic engineers, and this was like some of the like advanced use cases that we can use network automation, but you really need to have build a lot of things in place before you can actually start doing those with confidence. And so we're going to have a quick chat about orchestrators, because that's generally the first thing that comes to my mind when people talk about network automation. And so how many people here have like a network orchestrator in their environment, like from the vendor? A few hands. And how many people are happy with the network orchestrator or think that it's delivered on the promise? One hand. Okay. Just briefly, I'm just gonna kind of like define what orchestrators are, because there are many tools, and sometimes like the boundary of what an orchestrator is can be a bit touchy. So it's generally like an orchestrator is like a platform that like does executed like that executes like automated workflows. It does that across multiple domains, devices, and tools, and with the intention of delivering a service or a change. So that's what an orchestrator is. And so some of the common pitfalls I saw in some of the in some of the environments is having like a network orchestrator that is generally like very good in doing things like, let's say, building a new data center. Like you'd see many orchestrators in which like with one click and you have like a data center built, but then once it comes to do like day two operations, it takes 20 plus clicks to like add a VLAN. And so for me, like that kind of like really beats the purpose. If it takes more time to do it through the orchestrator than doing it in CLI, then that really doesn't make sense. A second one is let's say when you're doing things programmatically with the orchestrator, and then let's say something that would take you one call to make through the switch, you have to like make 5 API calls to do that one action. No one click rollback. It's like 2025, and I think like if the orchestrator is not able to do that one click rollback, I think that's like a big red flag. Like we should be able to get like a one click rollback from the orchestrator. That should be like a basic functionality. And the last one is poorly documented and inconsistent APIs. That's something that's also we need to look for. So what I'm going to talk here in this slide is like an alternative approach to orchestrators, or how we can take things into our own hands. So how do we deploy network as code, and like to be like in line with let's say with the cloud. And so we start like with a YAML file, and that's basically YAML is like it stands for YAML Enter Markup Language, which is not a very helpful definition, but what you can think of YAML, it's just like a way of structure, like storing like data in a structured way. So if you're familiar with Python, that's like the same as a dictionary. It's just like key pair values. So we use the YAML file as our intent document, and it just has like the minimum variables that we need to deploy something. For example, if we're deploying BGP, that would be just like the IP address and the BGP ASN. It wouldn't include things like the timer or things that are very consistent across multiple deployments. And the second part we have here is a Jinja template. And that's basically like a template that holds the code or holds the command line. And so by blending the two, like just like with a small Python script, that's where we get our config. And the reason we do this is this should be consistent across different vendors. You'd always have the same YAML or the same intent. If you have multiple vendors, then you would have like one template for each vendor. And so what you have here, then you can produce the config file. And then from the config file, you can use something like Ansible or any other like workflow or orchestrator that you have. And then you can push things to your devices. And this is just like assuming like even a legacy deployment in which, let's say, you only support SSH. This supports that. But now many vendors support like newer ways of pushing config to devices, such as like OpenConfig or REST APIs and all that. And so when it comes to measuring success, I always say like always benchmark before you automate. It's always very important so that you can know like what improvements you have made. One of the main things that we usually measure is like the time saved. So that's like the main metric that we have is measuring the time that we have saved. And then from that, you can actually calculate cost reduction. So if you multiply the hours that you have saved by how much it costs, let's say the hourly rate, that's how you get the cost reduction. Automation coverage is kind of like a long-term one, and that's like you calculate how many of your changes have been done manually versus how many have been done in automation tools. And the last one is automated network tests or safety, and that's like basically how many like related valid checks that you have in your environment. And so the key takeaways. So if I wanted to leave you with a few things here is to, when it comes to network automation, to start small, like build your use cases and then scale from that. Balance like quick wins with long-term strategy. And then to always like choose simple solutions over complex. Every tool, every line of code needs to justify its existence because things can grow out of proportion. And then the last thing is that automation is a capability and not a one-off project. So it's something that we really need to invest with over time.
Thank you, Mr. Al-Sabri.